Okay, for the introduction, the Orifice experiment is conducted to analyze the flow behavior of a fluid as it passes through an orifice or small opening. While flow velocity and discharge can be estimated using Bernoulli's equation, these values must have adjusted to account for energy losses in the system. To improve accuracy, it is necessary to determine the coefficient of velocity CV, the coefficient of contraction CC, and the coefficient of discharge CD for the orifice. These dimensionless coefficients are essential for calculating the actual flow rate through the orifice.
Theory of orifice can explain the behavior of fluids through an opening because orifice represents an opening at either the base or side of structure such as the. This is based on the fluid mechanics principle that can be understood through Bernoulli's equation and continuity equation. There are two types of orifice, which is small and large orifice. The difference of these two is just the size of the opening. There are a few equations such as coefficient of contraction, velocity, and discharge coefficient. The coefficient of contraction shows how much the water stream gets smaller after flowing through the hole compared to the size of the hole itself. The coefficient of velocity shows how close the actual speed of water coming out of the hole is to the ideal or calculated speed. The discharge coefficient is a dimensionless number that shows how much actual flow passes through an opening compared to the ideal or calculated flow.
So we finish our experiment. Now let's talk about the result. For the result, we use diameter of orifice 0.04 and 0.08, and then we calculate the distance in Y and distance in X. We also calculate the head level, and then we calculate by using the formula square root Y times H, and then we calculate also the flow rate. For the head level, the head level is the same for both diameter orifice. And then we move to calculate discharge coefficient. Okay, to calculate the discharge coefficient for the diameter orifice 0.04 meter. First, we calculate the area of vena contracta by using the formula pi d square over 4. For the diameter, we take 0.02 for diameter vena contracta, and then we get 3.14 times 10 power of negative 4 meter per cube. And then we calculate the velocity jet at vena contracta. We use formula Q equal to AV, and then we get V 0.072 meter per second. And then to calculate the discharge coefficient for the diameter orifice 0.04 meter. First, we calculate the area of vena contracta by using the formula pi d square over 4. For the diameter, we take 0.02 for diameter vena contracta, and then we get 3.14 times 10 power of negative 4 meter per cube. And then we calculate the velocity jet at vena contracta. We use formula Q equal to AV, and then we get V 0.072 meter per second. And then to calculate the discharge coefficient for the diameter orifice 0.04 meter. First, we calculate the area of vena contracta by using the formula pi d square.
Next, I'll be explaining the discussion of our results. From the experiment, we obtained the discharge coefficient for two different orifice diameters, 0.04 meters and 0.08 meters. For the smaller orifice, the discharge coefficient CD was calculated as 0.0065, while for the larger orifice, it was 0.0112. This difference happens because the flow behavior changes with the size of the orifice. The larger the orifice had a higher coefficient of velocity, which shows that the jet experienced less energy loss due to friction. However, its coefficient of contraction was smaller compared to the smaller orifice, meaning the jet area at the vena contracta reduced more significantly. These factors together affect the overall discharge coefficient. Besides, some experimental errors like slight inaccuracies in measuring the flow rate or water level, or even air bubble in the system could have influenced the results. Overall, this experiment shows how the orifice size plays an important role in determining flow characteristic and efficiency.
In conclusion, the orifice experiment helped us to understand how the fluid flow through an orifice and what affects it. We found out the size of the orifice play an important role. Larger orifice allow more flow and give more stable result. In this experiment, we successfully determined the values of the coefficient of contraction CC, coefficient of velocity CV, and coefficient of discharge CD, which help describe how the fluid behave. The difference between our result and the theory show the importance of the carefully measurement and avoiding errors. This experiment is useful in real life, especially like system like water pipe, fuel system, and flow meters, where it is important to control and measure how fluid moves through the openings.